I think we are ready to start. It's 5 o'clock here in Central Europe, and welcome everyone. My name is Sudeshna Borosaikia. I'm a Lisa Meitner Fellow at the University of Vienna and one of the members of the IAU Junior Members Working Group's Executive Committee.
Hello, I'm Fatmata Kibi. I'm the co-chair of the Executive Committee of the Junior Members, and I'm working at Spaceable, a French company working on space debris.
So today we have Chris Lintott, who's going to give a talk on Publishing Without Perishing, a User's Guide to the Astronomical Literature. So before Chris talks about this wonderful topic, I thought I'll briefly introduce Chris. And Chris is a professor at the University of Oxford, where he's a professor of astrophysics, and he arrived there after studying in Cambridge and at University College London. He also spent some time at the Adler Planetarium in Chicago. Since 2016, he has been the lead editor for laboratory astrophysics, software data and instrumentation for the AAS journals, including AppJ, and is the founding editor of research notes of the AAS. His own research focuses on galaxy evolution, machine learning, and citizen science, the latter as principal investigator for the Zooniverse and Galaxy Zoo projects. A warm welcome to you, Chris, and warm welcome to everyone else. So before we start, I think Fatoumata would like to talk about a bit of the logistics today.
Yes, thank you. So we'll have a 30-minute talk by Mr. Chris Lintott, followed by 30 minutes of discussion, during which Mr. Lintott will answer to the questions you have asked when registering to the webinar, and also to the live questions. So please use the Q&A feature on Zoom. And for those of you attending the webinar via YouTube, please use the chat. And if we run out of time, we will do our best to take notes of the remaining questions and provide an answer later in writing. Thank you.
So it's all yours, Chris, now.
Great, thank you. And hello, everyone. Thank you for joining me at what I know for lots of people is an extremely busy time, whether that's because it's the end of term or you're knee-deep in Gaia Data Release 3, which just came out. I'm enjoying the results on Twitter already. So thank you for coming. I think this is quite a difficult talk to give, but let me start showing my screen because of two things, really. One is that scientific publishing, the astronomical literature, if you like, is absolutely central to our lives as researchers and astronomers. It's vital to our science, and it's vital in many ways to our careers, which is why I think lots of you are here. But it's also not something we're very good about talking about. Until I became an editor, I'd never sat in a talk by anyone about the scientific publishing process. And as a result, I think lots of people think they know how things work, but without necessarily having ever looked underneath the hood of the journals and other publications that keep us going. And so I'm going to try and talk at a fairly straightforward level, assuming that you don't know anything. Some of this will be new to some of you, some of it won't. Please bear with me. And I think there is a message there for everyone. And on that note, I'll start with a disclaimer. It's great to have that introduction. But I think it's true that if you take N astronomers and you put them in a room, there will be at least N opinions about how papers should be written, how the publishing process works, and how the publishing process should work. And so this is my opinion that you're getting. That's informed by my work mainly on galaxies, though I dabble in exoplanets and I have been an astrochemist. I've done a little bit of cosmology. It's certainly true that different subfields have different practices. And so apologies if I don't take that into account enough. I'm certainly aware that in particular planetary science or instrumentation, which I'll mention briefly as we go, some of the things that I'm saying may not apply. And I, of course, come from a biased perspective. I'm lead editor for AppJ, AJ, and the AAS journals. So you should take that into account as well. But I thought I'd start a little bit as an illustration with a historical story with, I guess, the most famous astronomer of all time. Galileo's attitude to publishing was a little different from ours. You know perhaps of his books and his publishing that way, but he first communicated many of his great scientific discoveries by sending anagrams to his friends. So, for example, after one set of observations, in several letters to friends, he sent the following. He sent the string of letters, which is on the screen now, which I'm not even going to try and pronounce. I don't think it's a meaningful word in any language. And this is a very strange form of scientific publishing because it doesn't communicate anything. Why is he doing this? Well, the idea is that this is a record of something he's discovered that he can decode later. So he wants to keep the advantage of having information to himself, but he wants to be able to say later that on a particular day he had already discovered this. This particular anagram is famous because Kepler, who was watching, decoded this and thought it was a message about Mars having 2 moons, but actually it decodes as, I have observed the highest planet is threefold. Your Latin might be better than mine. So this is actually a discussion of his discovery of the rings of Saturn. But I think this story is interesting because it really breaks out the different ways that explain why we publish. So Galileo is very concerned with getting credit for his discovery. But the other purposes of publishing are really to communicate, which he wasn't even trying to do. We're trying to get across our science. We are also publishing for the historical record. It's often a record of work done for future generations. I'm a big fan of papers that cite the historical record. It's great when you're sitting there and it's got a reference to 2018, 2019, 2020, and then 1943 or whatever it is. And also we publish because there's some sense that science should be reproducible, right? In the sense that if I am making a scientific claim, then you should be able to reproduce the work that I've done. So if I take that wonderful Gaia data set and I do an analysis with it, and I make a claim about, I don't know, the Milky Way's metallicity based on that work or the Milky Way's history, then you should be able to reproduce that work and test that for yourself. And the mode by which we do that is through formal writing in scientific papers. And what's kind of interesting is that all 4 of these things were present right at the start of the scientific journal. So the first scientific journal, I think, in the world was the Philosophical Transactions of the Royal Society, which still exists. It's from the mid-17th century. I like, by the way, that the first edition of Phil Trans had an astronomy paper in it. This is, in its entirety, the discovery of the what might be the discovery of the Great Red Spot on Jupiter. There's some controversy as to whether this spot is our Great Red Spot, but it's a report of an observation by a person, so they get credit. It's communicated to the world. It tells you what time the observation was made, so you could, in theory, reproduce the observation by making a similar one. And there was this sense that this was vouched for by being in the journal. Even in the early days of Phil Trans, while they didn't have peer review, which I'll talk more about in a sec, that comes later, they did have the sense that they had to be careful to only publish the good stuff, the real stuff. And that's been very important throughout the history. So Phil Trans still exists, but it's not really used by astronomers. So I think it's good to talk about the landscape. And one way of dividing this up is to start with what might be called prestige journals. So typically Nature and Science in our fields. So these are cross-disciplinary international journals that claim to take only the most impactful and exciting science. You may have heard many people tell you that papers in Nature and Science are important for your career. And the logic behind that is supposed to be that people in astronomy know about the value of some of these other journals, but anyone in a university knows about Nature and Science. As I'll talk about in a second, I'm not utterly convinced that that's true, but it's certainly true that there is status and attention that comes with getting a Nature or Science paper. And those are journals that the first hurdle you have to clear is whether your paper is even interesting enough to be considered before it gets sent out by review. In astronomy, I think it's fair to say that we then have the big 4 journals, so APJ and AJ, the Astrophysical Journal and the Astronomical Journal, run by the American Astronomical Society, are run by the same people, but both exist. There's Astronomy and Astrophysics, which is run by the European Astronomical Society, and monthly notices of the Royal Astronomical Society. So most astronomical literature ends up in these 4 journals, and they all behave in roughly the same way. Crucially, they all have quite high acceptance rates. So I think I say this later, but across the journals, I would estimate that about 85% of papers submitted to these journals get accepted after rounds of review. And that makes our field rather unusual. In most fields, you apply to a top journal, which might have an acceptance rate of 10%, and then you rework your paper if it's rejected, and you keep going until you find a journal lower down the food chain that would take it. That process can waste a huge amount of time, whereas in astronomy, at least, though it's frustrating and it often time-consuming to go back and forth with a journal and perhaps a referee, we do have the advantage that we don't have to worry about continually resubmitting to other journals. And of course, the Big Four don't publish everything. So I wanted to highlight particularly New Astronomy, publications of the Astronomy Society of the Pacific, publications of the Astronomical Society of Australia, all of which publish regularly high-quality journals. The one missing from this slide that's becoming more prevalent is Nature Astronomy. I wanted to distinguish these, so I talked about Nature as the prestige journal. Nature Astronomy is a spin-off, a separate journal with its own editorial standards, which concentrates just on the very broad field of astronomy. And so I suspect that in a couple of years, when I have more stats, the Big Four look like they're becoming the Big Five, and Nature Astronomy will fit in alongside APJ and so on. Several of these journals also have supplements, which are sort of for longer, more technical papers, but there's also this idea of a letter. And the idea of a letter made perfect sense when journals were printed. So a letter would be rapidly produced, rapidly processed, and inserted into an edition of the journal faster than would otherwise be possible, so that people could communicate the latest science. That idea sort of survives, for example, with APJ letters, and Monthly Notices has an online section as well. These are separately edited, rapidly processed, very rapidly processed in our case, and there's a higher bar, so one would expect that to have more original research or more exciting or important research to be in APJ. For example, the Event Horizon Telescope stuff, some of that ended up in APJ letters. There's usually a presumption that letters are short, although these days there's no hard limit in most cases, so you can publish a very long letter. While we're looking through journals, I said I'd nod to Beyond Astrophysics. So cosmologists have a different set of priorities. They tend to publish much more like physicists. So there's PeerReview, PRL, JCAP. If you're a cosmologist, you'll know these places. If you're an instrumentation person, then publishing via SPIE, the conference series and journal can be important. And if you're a planetary scientist, there's the new Planetary Science Journal. Icarus is a long-standing journal. You might publish in geophysics or atmospheric journals as well. So apologies again for being astronomy centered. And of course, if you're doing something on machine learning that overlaps with modern computer science, then computer science publication is different. Computer scientists tend to publish via conferences. And so the big thing in computer science is to get your paper accepted by a conference. Working further outwards, there is still there are some outlier journals. I really wanted to mention the Annual Review of Astronomy and Astrophysics, a journal which accepts papers, as far as I know, just by invitation. So they will write to you if you want a review, but it's a wonderful source of really thoughtful, long papers that cover whole topics. And if you don't already make a point of reading at least a couple of the articles from the Annual Review, then I highly recommend it each year. And my own pet project at the other end of the scale is Research Notes of the AAS. So Research Notes is not a reviewed journal. We publish short papers, 1 or 2 pages, which are moderated by me and editors, and there's no requirement to be interesting at all. So this is a place to put negative results, short observational notes, updates, works in progress, and things like that. So for example, this was a short note by Jesse Dotson and co, making the point that there were more planets to be found in Kepler's K2 dataset, but not trying to find those planets. And then finally, in my whistle-stop tour of journals, I want to point out that lots of us write software during our scientific careers, and publishing about the software and publishing the software is becoming more common. So I'm very heartened by the existence of the Journal of Open Source Software. This is a journal that actually reviews the software. So you submit your code with a short descriptive paragraph rather than a paper about the code. And the code is reviewed by experts. A large proportion of JOS's papers are astronomical codes. And so I recommend that as an option. And also, along with others at AAS Publishing, we've become very positive about short papers that describe software. So if you've written a code that you're using in your research, you can write a 2 or 3 page paper in the Astrophysical or Astronomical Journal that describes that for an audience of astronomers. And I highly recommend that you do that so that you get credit for the work that you've done in preparing software. So with all these journals, I guess the obvious question is how one would choose. On the left there, we've got a little bit of advertising from monthly notices, but I think that there are a few factors. One is habit. Many research groups always publish in the same journal for historical or other good reasons. The other is reach. Who are you talking to? To some extent, I think all the journals these days are accessible by many people in many institutions, but it used to be that there were geographical places. Journals have to pay for what they do, and several of them are profit making. So there's a cost. Sometimes that cost falls on institutions via library fees, but sometimes you have to pay per page. So for people without money to pay page charges, then that might be a problem. And sometimes you may particularly like or dislike particular editors who are going to be dealing with your paper. Often, for many people on many grants, there is a requirement to publish in an open access journal to make sure that people can get access, anyone can get access to your paper. I think this is a very good thing to do. And there are 2 types of open access policy. So there's gold open access, in other words, where on publication, the journal allows anyone in the world to access that article. That often means that you pay a fee. Or an enhanced page charge fee. We just saw this week Nature announcing their page charges for open access. But there's also a form of green open access, which is when the journal agrees that you can make the paper freely available. And that's most common in our field. And for astronomers, that tends to mean putting papers on archive. So if you are taking your accepted paper and you're putting it on archive, that's more or less compliant with green open access. And I'm pretty sure that most of you watching will be familiar with archive and perhaps with the growth of papers on archive. So our bit is this red bit in here. That's the growth of AstroPH since the early 90s. And what this tells you, and I could have updated this trend has continued, is that the number of papers being published is enormous and growing. So the idea that anyone can keep up with the literature, as you know, is false. But it does give you a sense of the scale of the problem of the literature. So let's assume that you've picked a journal and that you're writing a paper. Often it's the other way around. What other things might you want to consider? Well, one thing that's very important is deciding who gets to be on your author list. And there are no hard and fast rules for this. Journals will tell you that everyone on the author list will have to have contributed to the paper. And a good test, I think, is whether they could write down what they did. And if you can't write, and that can be small, but if you can't write a sentence that says something about what you did for the paper, then you're probably not an author. I think that's fair. But that could be something quite far removed from the work in the paper. That could be built telescope that provided data, or it could be applied for telescope time, or it could be ran statistical analysis, or it might be built software that was used. There are many ways to qualify as an author, but hung around and had coffee occasionally doesn't usually count. And then you have to worry about the author, the order. So I would say that people really care about who the first author is. The first author is expected to have written most of the paper and probably done most of the work. The next few authors, in this case, this is an example from my own group, by the way, second and third authors were directly advising the first author or did large amounts of work. And then you can see from author 4 on here, this becomes an alphabetical list of other people. So we all contributed, but we contributed by discussion and by reading the paper in this case. Note, because it's caught me out as an astrochemist before now, in some fields, mostly those with big and expensive laboratories, the senior author goes last and is usually the person who provided the grant money. So that's not something that happens in astronomy very often, but it's worth noticing that happens. And of course, the number of authors on papers is increasing to the point that LIGO and very big collaborations have started just putting a list at the end, and you see LIGO papers appear as LIGO collaboration et al. Gaia papers tend to appear as Gaia collaboration et al. And so on. So your written paper, we'll talk a bit about writing papers in a bit. You've come up with an author list, you then submit it to the journal. And the way to think about this is essentially a very obscure sport. So as an author, you submit your paper, it typically goes to an editor. So who is an editor? Well, in most cases, editors are academics or researchers in the field, and obviously they work in a field that's relevant to the journal. There will be an editor-in-chief who in most cases will be full-time or nearly full-time on journals. You probably shouldn't hear from them unless something's gone very wrong. But there will be a scientific editor who will be assigning referees and making judgments about your paper. So it's the scientific editor that you interact with. You may also correspond, depending on the journal, with an assistant editor who probably has a science background, maybe not an astronomy background, and is responsible for actually making sure the whole thing works. But in this case, let's talk about scientific editor gets your paper. Their first task is then to find a referee, and they'll do that based on their knowledge of the field, but also what you've written in the paper, and also perhaps advice from colleagues. And so I spend my time as an editor mostly emailing potential referees and saying, we've just received this paper, here's the abstract, would you like to review it? So referees are your peers. They should be fellow academics working and probably publishing in the same field or fields. That means that referees are right and wrong just as often as you are. And so just because you're refereeing a paper, it doesn't sadly give you any special status or access to the truth. In astronomy, this is important because in astronomy, the big journals tend to assign a single referee, which makes us a rather unusual field. In other fields, 2 or 3 referees are common. And we ask referees typically to respond in 3 weeks, but they're unpaid. And so it can easily take a couple of months to get a response. There's an ethics of refereeing, which I don't want to go into in too much details, but journals have their own conflict of interest policies. But broadly, if you're asked to referee and you don't think you could be fair, sorry, there's a typo on the slide, then you shouldn't referee. And if you don't think you would be seen to be fair, particularly by the authors, don't referee. It's fine to say no, and it's also okay to ask the editor for advice if needed. If you're asked to referee, then the most important thing is to be nice, even while you're being critical. You're there to critique the science, you're not there to critique the people. And as editor, if I see comments about a person or about somebody's status, you know, I can't believe that this PhD student did this, I will delete those comments, but I shouldn't have to do that. There's no need to attack people instead of the science. And equally, on the referee front, please don't copy edit. Don't feel you have to go through and improve the English or you know, find the typos. The journals will do that, and that's something that happens later in the process. As an author, if there is somebody in the field who you don't want to referee your paper for whatever reason, most journals are fine with you just saying that. So when you submit the paper, just say, I don't want this reviewed by this person. There's no need to give an explanation, and that's perfectly fine. If you list everyone else working in the field, then we may need to have a conversation with you. That has happened, but it's perfectly fine to say, look, this person I think has a problem with my work. Please don't send it to them. And if you're also worried about that sort of thing, many journals are experimenting with double-blind reviewing. We are at the AAS journals, where the referees don't know who the authors are. It's kind of difficult because you have to write a paper in such a way that doesn't make it obvious who you are, but this is an option that's available if you're worried or working in a highly competitive area that you think this might be useful. So the paper goes to the referee writes a report which then goes back to the editor. And at this point, you can think of the editor as the referee of the game. So I think sorry, that's a terrible sentence. You can think of the editor as the umpire of the game. There's a common misconception that the referee makes a decision about the paper, but the referee makes a recommendation to the editor, and the editor does not have to follow that recommendation. So if the referee says, I think this is a brilliant paper, you should accept it, I have no other comments, as an editor, I'm likely to go and get another referee. Equally, if the referee says that the paper is awful and gives no reason, it's perfectly within my rights as an editor to accept it. And so it's important to realize that there's that distinction. The referee is providing information to the editor, who then makes the decision. And when you've gone back and forth a few times and everything's okay, then we get a new character of a publisher who then takes the paper. So we now have a published paper out in the world, and we want to know how good it is. We want to know how well it's doing. And the way that people tend to use this or to investigate this is via citations. So a citation in the paper, as you all know, I'm sure, is a reference to a previous paper. And so if your paper is doing well, then presumably lots of people are citing it. Doesn't take much to realize that that's a fairly crude measure. A good way to have lots of citations is to be famous and wrong, because then everyone will write papers telling you that you're wrong. And also some very good papers take a long while. So this is Zwickie's paper from 1937, which includes the first discussion of what we'd call dark matter in galaxy clusters, which didn't really start getting cited until the late 90s, and yet is a canonical piece of work. So the number of citations is not a measure of how good the work is. It's a measure of how many people have paid attention to the paper. But unfortunately, people often use it as a measure of how good the work is. So because it's used like that, it's important to understand when to cite. And if you're writing a paper, and I want to give two answers to that. So one is that you should cite all the papers which influenced your work in any way, which seems kind of reasonable. I think a more useful rule is that you should cite liberally the relevant papers in the field. So if you're writing about the discovery of a Saturn-sized exoplanet around a particular kind of star, and another group has published a Saturn-sized exoplanet around that kind of star, which you don't talk about in the paper, under the narrow definition, there's no need to cite them. They didn't inspire your work, you didn't use them. But it's a bit rude not to mention that they found their planet as well. And I think if you follow the broad definition here, you're less likely to end up in long and angry email exchanges about citations. But there's no need to list every paper ever published on a topic either. So these citations are collated. We're lucky. Another reason that astronomy is unusual is that we have the ADS, the Astrophysics Data System, which is a remarkable tool for exploring the literature, but it's also a graph of every citation in the astronomical literature. So the ADS keeps track of who cites who, and it does so in a very open way. In most other fields, you have to pay quite a lot of money to get access to that information. And so you can look up and keep track of how you're doing. I was pleased to see this morning that I've topped 9,000 citations. But in this, so this is for my papers, in this ADS graph, there's this strange thing given called a H index. And you may come across H indices. So the H index is an attempt to quantify how good a person is at science via the citations that their publications get. And the rule is pretty simple. So your H index is a number. so mine's 46, I think. If you've published so your H index is H, if you published H papers which have been cited H times. So the fact that mine's 46 tells you that 46 of my papers have been cited 46 times or more. By the way, notice that I haven't ever written a single author paper, so it's a bit strange to talk about my papers, but never mind. The problem is that this index was invented and tested for theoretical physics, where there are a lot of single author papers, and it's been shown that you can't compare across fields or possibly even subfields in astronomy this way. So if you're a theorist, your H index is likely to be very different than, say, somebody who works on the Gaia data release, right, who's about to find themselves on, or the Sloan data release, which was a survey that allowed large numbers of people, because they put effort into the survey, to be on lots of papers. It's hugely problematic as a person. So I would strongly advise you not to use the H index, because citations don't reflect the quality of a person. They reflect how much attention those papers have got. Sometimes people use citations to analyze not the people, but the journals. So one thing you'll see if you spend time on journal websites is this quantity called impact factor, which is a sort of metric that the journal industry has decided to use to market papers. It's compiled by a company and announced every year to great fanfare. So, but roughly the methodology is fairly straightforward. So the impact factor for a given year, for a given journal, is the number of citations that journal's papers received divided by the number of publications from the 2 previous years. So it's that 2-year window is important. And the trouble is that this is heavily skewed towards highly cited papers. So I'm imagining that, I haven't looked, but the Gaia data that came out today will be in ANA, I would think. And that paper, I would imagine, by in the next couple of years, will probably gain 2,000 to 3,000 citations. So ANA's impact factor will go greatly up because of it. But that doesn't tell me anything about the average quality of a paper in ANA, which may be good or may be bad, but we don't know from the impact factor. And yet journals use it as a number. It's also not stable. So I thought this was quite fun. This is work by Frank Timmis and colleagues. So this is the top 50 most cited papers published in 2010 in astronomy. And you can see how they move. Think of this as a league table from a sport or something. And you can see how they move over time as you go from 2010 to 2019. And what you can see is that even the top 50 most cited papers are not very stable for the first 5 years after publication. So papers that get an initial burst of citations often become less important in the long run. And some papers which get ignored initially slowly become recognized as much more important. You can actually quantify that. So 2/3 of papers, so this is time since publication, and this is the percentage of articles that were in the top 50 after the first year that remain in the top 50. And all I want you to see really is that gap on the right there, where I've got the text, 2/3 of the papers which seemed most impactful at the start drop out of the top 50 within the first year or first 5 years or so. So long-term impact isn't the same. And so one really has to take these citation metrics with a pinch of salt. So this is all deep in the weeds, but I think it's important to understand this stuff, because when we're talking about publication, we're really talking about careers. And people think that if you publish in the right journals, you can click the right metrics over and you get your H index up, or you get your Nature paper that's been cited 50 or 100 times, that will get you the next job. And it's not quite like that. What I think is the thing that will most improve your chances of advancing in whatever astronomical career you want to have is to write papers that people actually read and that people talk about and that people are excited to see, because people's reputations are made by such papers. And those are not necessarily papers in the best journals, not when everything is accessed via archive, or as I show here, ADS anyway. And they're not necessarily papers that immediately get lots of citations. They're well-written papers. And so let me finish by defining a well-written paper and tell you a trick, I think, which will increase your chances of writing one. So one way to think about this is to always consider two audiences when writing. And the first audience is somebody who's just found your paper on their morning scroll down archive, who has decided that they're going to look at it. They haven't decided to read it. They haven't decided to study your paper. They haven't particularly decided they're going to spend much of their day on it, but they're intrigued enough to at least open it. And what will determine how well they like your paper is whether it tells a good story, whether they can quickly understand what the purpose and results in the paper are. And that probably doesn't mean they're going to start at the beginning and keep reading. So the famous, if section 2 is your traditional methods and section, most people would read that last because you only care about that if you're going to try and work with the results. First of all, I want to know what your conclusions are. So I often start from the back or look at the figures. And so when you're writing your paper, it's worth making sure that you have a coherent story and it's told easily. I also think that you can help yourself by making sure it's clear which section is which. Start each section with a description of what it's going to contain and end each section with a little mini summary so that people who are jumping around can understand. That's really, really important. So that's the first audience. Can a casual reader understand your story? And I have to say, I've hired postdocs based on reading papers of theirs that I found have been compelling. So I think this really, really does matter. The other audience is what I think of as the poor PhD student. So somebody who's been told, this paper by Lintott et al. Is just excellent. We really should do this, follow their analysis, but with our data. Let's see if we can reproduce their results. The student goes away and starts looking at the paper to work out exactly what you've done. This is a very different form of interaction with a paper, but it requires attention to detail and care so that people can reuse your results. And these figures are from, the figure on the left is from a paper that I wrote when I was a PhD student. It's a reproduction of a classic figure on the right from Blumenthal, Faber, Premack and Rees from 1984, which was one of the first papers that looked at dark matter in the context of large-scale structure. And I spent ages trying to track down the little hashed things there in the middle, which are labeled IIR, SC, SB, SA, SO, and E, are all galaxies. And I spent ages trying to get modern galaxy measurements to lie on the same part of the plot, and eventually I managed that. But the dots are all dwarf galaxies, and I could not get modern dwarf galaxies to lie on the same plot. And I spent 3 months trying to do this before I realized from conversation with the authors that they were sort of schematic. They weren't data. They were a guess as to where things might end up. And so if they'd said that, I would have saved three months. So apologies to these very senior people, but I still want my 3 months back. And if they'd taken care of the poor PhD student, then I would have saved that time. So how do you learn to do this, particularly the first piece about reading casually? I would suggest an archive challenge. I think you learn to write good papers by criticizing to yourself, rather than necessarily out loud, other people's papers. So I would advise an exercise in which you go to AstroPH every day where you've got a few spare minutes, pick a paper at random and spend 5 minutes with it, and then write down what 3 things that you've learned from the paper. If you have done that, then you'll begin to understand which papers work and pass that test and which don't. And then you can ask yourself why that particular paper worked. Were the figures particularly good? Was the structure of the sections particularly good? Was the writing particularly clear? By doing that, I think you will start to be able to recognize what works and what doesn't in your own work. And that will help you with the fact that writing a paper is a difficult and miserable process in many cases, because one is so stuck in the detail of the science that we do that it's quite hard to look up and see whether you're doing a good paper. So now you publish your paper, you've written a good paper, we published it, we talked about editing. The next thing, of course, is promoting it, because your work isn't done when you've finished writing and submitting and editing and having your paper edited. The paper is the start of a conversation. And so it's really important to promote your papers. So you could do that, of course, via conferences, virtual or otherwise, given the world that we're in. And it's important, I think, to make sure that in your talks you refer to the papers. They're the things that provide the scientific record that back up the story that one can tell at a conference. So think of conferences as places to advertise your papers. There's of course social media. So astronomy Twitter, I found, is a reasonably friendly and supportive environment, and people will like to hear from you if possible about your work. The fact that I'm following the Gaia data release via Twitter is really exciting and interesting, and I really do think, and there is a small amount of evidence that papers that are discussed on social media end up getting more citations. So if we're viewing this as a game, you might as well play the game. So whether that's amongst your own networks, with your own colleagues, or on a social network such as Twitter, I recommend talking about your papers and making sure that they're there. As somebody in the questions I can see has already pointed out, what doesn't work is emailing large numbers of astronomers asking them to read your paper. We're all busy. There are too many papers, and so that doesn't work. But if somebody's given a talk that you like, or you see them saying something online or at a conference, then it's perfectly fine to follow up and say, look, I heard your talk. I thought you'd be interested in this in this way. So that capacity to promote your work and back it up with a paper is really important. So I hope some of that's been interesting. The takeaways I want you to remember are that while choice of journal is important and interesting, and I'm supposed to be talking from a AAS journal's perspective, honestly, the amount of effort that goes into worrying about such things is much less important than the effort spent writing a good paper and promoting it. And publication is about communication, right? That's why we're doing this. And if you haven't communicated your science clearly and effectively through writing a good paper and then talking about it, then you haven't finished doing your science. You don't get any credit for secretly solving the mysteries of the universe. So thank you very much for listening. I'm happy. I think I've just about saved us some time for questions. So I'm very happy to discuss whatever it is that you would like to discuss.
So thanks very much, Chris. It was very interesting and loads of things that we usually don't think about when we write a paper. So I'm sure that our audience also learned a lot of new things. So you already talked about what are the key things that you should keep in mind more or less when you're writing your results up in a journal article. But I suppose I'll start with a question on the high impact journals that you talked about, for example, Nature and Science. So in addition to the tips or the methods that you discussed already, what kind of extra tips do you have for young researchers, early career researchers, to publish their work in Nature or in Science?
Well, you're asking the wrong person, because I've never managed to publish in Nature or Science. And as a PhD student, I have a very strong memory of submitting to Nature, walking home and being rejected within 15 minutes. Because the first step for Nature and Science is this interesting, and they weren't interested in my ideas about sulfur chemistry around early galaxies, which I'm still upset about. But I think, look, those journals think that they're looking for headline results, right? They would like to publish things that are going to have a big impact now. So if you want to publish in Nature and Science, I think a good way to filter is to ask yourself whether you could write, it's not the only way, but whether you could write a press headline about your discovery. Is that's not a sort of a press headline that astronomers would care about? Can you summarize your result in a single sentence? Then the other thing that's worth saying, I think, is that those journals have a very different style. They read differently from other journals. And so they have quite specific guidelines. Nature, I think, has a line-by-line guide to what your abstract should look like. The 7th line should contain details of future work or something like that. So if you want to try for that, you really should go and read some nature and science papers in your field and get a feel for it. But I don't want to be too negative about people publishing in nature and science. I think, you know, if it can boost people's career, then it's good. But as a field, I'm very worried by the idea that which journal you publish in tells you whether that's a good paper or not, because we can see that the evidence is that that's not the case.
Mm-hmm. Yeah, I think I quite agree with you on that. So do you think that Nature Astronomy is a journal that works more or less like our big 4 journals in astronomy then?
Yeah, I don't. What I wanted to do for this talk is look at data, but because Nature Astronomy is new, we don't know yet what. So because as I've shown, I think very briefly in passing, it takes at least 5 years to work out for things to settle down. So in a few years' time, we'll be able to see what kind of papers with long-term impact end up in Nature Astronomy. An advantage of Nature Astronomy is that it's easy to submit to if you're rejected by Nature. So if you submit to Nature and you get rejected, then it's very easy because you're in the right format to submit to Nature Astronomy. But you know, they are commercial rivals of the non-profit publication that I work for. So I would rather they didn't exist, but people are publishing in there, and people are enthusiastically doing so. I think partly because it's amazing how often papers in Nature Astronomy are described as being in nature by people talking about them, because it gives you a bit of that branding. Whether that's effective when you apply for jobs, I'm not sure.
Okay, so yeah, thanks very much. So Fatoumata?
Yeah, thank you. And by the way, do you think that it's not going to put on the researchers a kind of pressure to publish in Nature, like to have a short-term data to have a big impact?
Yeah, I think that is the effect of those journals on the field. And I think people get advice. They're told that they will get better jobs if they have nature papers. And I'm not utterly convinced that that's true. I don't see much evidence that that's actually true. Okay. Having good papers that get noticed definitely helps. But I'm not utterly convinced that anyone cares about which journal it's in anymore.
Okay, and do you know for one of the journals you work for, the number of times it did not follow the referee's recommendation?
Sorry, how often do authors not follow the referee? Is that the question? Sorry, I lost you for a sec.
Excuse me. It's how many times the publisher did not follow the recommendation of the referee?
The publisher. So,
the journal.
The journal.
Yeah, the journal.
As an editor, probably. So I can speak for myself, and I think this is consistent with my colleagues. So I think probably 5 to 10% of papers I end up getting another referee, or I end up asking the referee for more information, or I end up editing their reports before they go to the author. So it's quite common. And sometimes that's a small thing. Sometimes 90% of the paper is fine and they're just disagreeing about one point. So I have to make a judgment as to how important that point is. Sometimes it's a big thing and then we'll get another referee. But I found out years later, so the paper that our first Galaxy, so the project that made my career was Galaxy Zoo. Our first paper submitted to a journal, I found out later that the editor had asked 4 different referees because the first 3 didn't consider it properly. And if the editor hadn't done that, I suspect I certainly wouldn't be giving this webinar. I'd be doing something else. And so it is important. And that's why I emphasize the role of the editor, not to make myself look important, but to remind people that there's another player in the game and that it's fine. If you don't like the referee's report, and you've got good reason for not liking the referee's report, it's fine to say to the editor, look, we're not having a good discussion with this referee. I want another referee. That's hassle and it will take longer, but you're allowed to do that. You don't have to convince a referee who you completely disagree with. You can ask the umpire to step in.
Thank you.
Okay, so I'll continue on that earlier discussion again, a little bit slightly different. So these are questions that we had from our audience that we asked beforehand, and also some questions that we have from the live audience as well. These are all related to publishing in different journals. For example, you mentioned about these nonprofit journals that you are working with, and also journals that are commercial journals, for example. And now we have arXiv, which I think astronomers are using quite a lot. So historically, there is and you showed as well. So in that context, so then can people just publish something in arXiv? I mean, is it still considered to be, I suppose the problem is that there is no peer reviewing in that particular case if you don't submit to a journal, but is there an alternative to that?
Yeah, so I think the thing to do is to divide what the journals are doing for you, right? So one traditional job of the journal is to disseminate, to publish and literally post out the article, right? arXiv does a perfectly good job of that. If you can get your thing onto arXiv, which is incidentally moderated, but if you can get your thing onto arXiv, then it's there for astronomers to see, but it's not reviewed. And while not all peer review doesn't mean your paper is true, it's at least accepted as a minimum standard, and arXiv doesn't offer a review. So I certainly think if you're aiming for anything in close to or adjacent to a traditional academic career, people will look at peer-reviewed papers. One thing I forgot to say though is that different parts of our field have different cultures about arXiv. So if you're a cosmologist, I think it's fair to say that it's expected that you put your paper on arXiv before it goes to the journal, on the grounds that you want people to comment before you bother a referee with it. If you work in planetary science, that would be very unusual. In fact, it would be almost considered rude as far as I understand it. So they would expect the journal to accept the paper before it ends up on arXiv. And so you do have to ask people in your field about. There are a couple of interesting attempts which I didn't mention. So there's something called the Open Journal of Astrophysics, which is an attempt by Peter Coles in Maynooth in Ireland and others to bolt review on top of arXiv. So you submit to arXiv, they review it, they give you a stamp, and then you've got a reviewed arXiv paper. But the number of papers they've handled so far is pretty small. So we'll have to see how it goes. It's also worth saying journals would justify themselves because they do copy editing. We improve the English where necessary. We will make the figures often look better and provide a long-term archive, right? So the journals are publishing things they think will still be accessible in 100 years' time.
So is that because you just mentioned it, so I thought I'll ask this question right away. So is that why you think there are still fees that you have to pay despite journals mostly not being published in paper format anymore? So is this where the money goes to?
So the money mostly goes to publishing and people. Right, so journal. I'm not an expert in journal economics, but mostly, so we pay. So the AAS journals, the editors are either paid or my time is bought from the university. So I don't get more money, but the university gives me some time to do this work. So that costs a bit of money, not a lot. But then we pay an entire commercial publisher, Institute of Physics Publishing, who do copy editing and typesetting and hosting and so on. So that's where the money goes. Almost all the journals have to make money that way. So either that's done with page charges, so you charge the astronomers, or usually it's via charging institutions. So it will come out of a library budget or so on. So for example, if you ask your librarian about the cost of subscribing to AppJ, which charges page charges and monthly notices, which mostly doesn't, you'll discover that they think monthly notices is much more expensive. So money is flowing to the journals from the academic system either way. It's just about how it's spent. And I think all of that will change dramatically in the next 5 years because the system is beginning to break. People don't have money for page charges. Institutions don't have money for library charges. There's a move to more open access, and I think things are going to change pretty rapidly.
So then on that note, so I think I'll ask the last question on this topic anyway. So you mentioned something about how in computational sciences, they do a lot of these conference publications, for example. So do you think there might be a transition in that direction, or is it viable in our field?
I think there's two separate things. So in our field, typically people do publish conference proceedings, and that's a good way of getting brief notes about what you're doing or ideas out. You can also submit those things to research notes. In computer science, it's very different. So you essentially write the paper, you submit it to a conference, it's then reviewed by a panel. You might go back and forth a few times, and then you end up at the conference if you're accepted. So getting into the conference is after all of that review. And it takes a long time, it wastes a lot of effort, and I'd strongly recommend we don't go there. But it's worth knowing if you're going to, lots of astronomers are beginning to work on the edges of computer science, and it's worth knowing that the publication rules are different there.
Indeed. So
yeah, so you gave us some advice on how to self-promote our work. What do you think about self-citation?
So yeah, so this is tricky. And a great question. So I think there is inevitably a degree of self-citation that happens. For example, if I want to cite the fact that not all spiral galaxies are blue, but some are red, there are lots of papers that wrote about that at the same time. But the one that's going to come to my mind is the one that I worked on, led by Karen Masters. So I'm just going to type Masters et al. And move on. And I think that's fine. And it's another aspect of why citation isn't a good metric for anything. We do occasionally spot people who say, galaxy evolution is an exciting and important field. See Lintott et al. 2008, Lintott et al. 2009, Lintott et al. 2010A, 2000, and those we will remove. And I think that's fair. But really, this is just citations, and we're used to, as astronomers, dealing with noisy data. Citations are really noisy data, and self-citations are one example, but it's also the case that, like, if I write, I need to pick on somebody, Martin Rees et al. Were completely wrong in their paper of 2019. That's a citation. They get credit for that. No one ever goes back and notices that I said they were wrong. And so the idea of citation is this universal good. All it tells you is that somebody interacted with your paper. So avoid excessive self-citation. Don't worry about it too much.
Thank you. And by the way, what do you think about people who write college textbooks or popular books for the general public? How it can be considered in our resume?
Yeah, I saw that this question come in. I think it's a really good question, and I think, you know, writing for college textbooks, writing for the general public, writing online, contributing technical manuals, software, and all of these things. These are forms of academic communication that aren't well captured by the traditional journals, and I don't mean to suggest that they're not important, but as I'm talking to an early career network, I think it's important to realize that the academic system values journal publication. It's set up like that, and I wish we could change that for all sorts of reasons, but it's very difficult. It's very entrenched. And so my advice would be to try and find ways to turn those activities into journal papers. So the AAS journals, we encourage people to write really short software papers that describe their software. But then you have an AppJ paper to ask people to cite. And then you can make the work that you did for software look like a paper. For college textbooks and popular stuff, that's harder. But you could, for example, write in Communicating Astronomy for the Public. So this is an IAU group. You could write about the use of the textbook, and then you have something that looks like a paper. I know that's not a complete answer, but it is a step towards it. Or you decide that you do those things for reasons other than getting academic citations and move on.
Thank you.
So unfortunately, I think we are almost running out of time. So there have been loads of very interesting questions that we have received today from the audiences, and I have to just pick one. So I hope we can answer them at a later stage nonetheless.
Sure, I'm sorry I talked too much. I apologize.
No, you had some very good points, so don't apologize. We had a great time listening to it. We wish that we could have had more time, but I'll ask the question then. So that question is a little bit more about advances that younger astronomers could have based on the number of publications they have, right? So you mentioned how the citation number is not a very good metric, or even H-index is not a very good metric to determine the quality of an astronomer. So what ways can you evaluate an early career astronomer based on your publication list? Are there measures that can be taken to make sure that you don't fall into this trap of just counting citations, for example?
Well, I think the advice to people making the selection is that they need to look at the papers. And there's something called DORA, which is the DORA. I can't remember what it stands for, but it's a declaration of principles signed by many academics and many institutions that say that they won't use metrics to make this kind of discussion. I think that's really important. But what that means is that if you're an early career researcher, you have to realize that if I'm on a panel looking at postdocs or something like that, I'm going to have a look at the abstract of the papers on your CV, and I might look at one of them. So really making sure that you've got a paper that works for somebody who's quickly looking at it really matters, because people in those sort of circumstances don't have time to sit and carefully read the paper. So I think that's my main advice, is to remember that we're a community that publishes a lot, that doesn't have a lot of time to read. And for all sorts of reasons, we need to communicate quickly in our papers. And then you can put all the detail in as well, and service both audiences. And I think the biggest failing I see with papers is that they fail to tell that story quickly, and that anyone glancing by would struggle to understand why what you've done is brilliant.
Okay, that's some very useful advice. Thank you. So do you want to wrap it up, Fatoumata?
Yes, so before we end this very interesting webinar, so I would like to advertise for one of the activities of our working group. So we want to recognize your work you're doing in your work, or also outside of it, like the outreach activities you can do. So please submit some photos you have taken during your activities and share it with us via email, Twitter, Dropbox, and our Slack channel that you can join now. And you have all the details here, and please follow us on the social networks. So thank you. And I would like to mention also the event of next week. So it will be a talk done by Dr. Gina Halabi from the University of Cambridge. It will be about how stories can shape realities on Earth and in space. It will be from 4 to 5 UTC time. So please join us. Sudeshna, do you want to?
So thanks from my side as well. Thanks very much, Chris. It was a very lively discussion, and we hope that we can contact you again to maybe you can answer some of the unanswered questions.
Of course. Maybe I could just say quickly, the best email address if people have questions is chris.lintott@aas.org. And those emails I will see easily, and I'll know they're about journals, and I can reply.
Sounds great. So thanks very much. It was very useful. And hope everyone have a lovely day, rest of the afternoon, rest of the evening, rest of the morning, wherever you are from at the moment. So we hopefully will see you again next week. And thanks again. Thanks very much.
Thank you.